My dear colleagues, I welcome you for my Brahma Gupta educational channel. Today we shall discuss something about three-dimensional geometry. Very previously we are known about the space, the geometry in plane or XY axis geometry. Today we shall discuss about three-dimensional geometry. When in 3D geometry there are three axes are coinciding: x axis, y axis and z axis. Let a line segment, that is OP, in this manner OP, if OP is a line that passes through the origin, if OP is a line in this space and the OP passes through the origin of this line, origins of the axis, then it makes angles with the x-axis, y-axis and z-axis respectively. That angles are cos alpha, cos beta and cos gamma. Here in a space, if the line OP pass through the origin, then OP makes angles. OP makes angles as cos alpha, cos beta and cos gamma. Cos alpha, cos beta and cos gamma. With axis are x-axis, y-axis and z-axis. Then OP makes angles cos alpha, cos beta and cos gamma with x-axis, y-axis and z-axis. Here the cos alpha and cos beta and cos gamma are called the directions cosines. Here cos alpha, cos beta and cos gamma are called as the directions cosines. X cos alpha, cos beta and cos gamma are the direction cosines. The directions cosines are denoted by the letter as L, M and N. Here, so cos alpha is equal to M, cos beta is equal to M and cos gamma is equal to N. And cos, then L square, L represents for cos alpha, L square plus M square plus N square is equal to 1, or cos square alpha plus cos square beta plus cos square gamma is equal to 1. It is the relation of the cosines. This cos alpha is equal to M, cos gamma is equal to M, cos beta is equal to M, cos gamma is equal to M. The relations of the direction cosines are cos square alpha plus cos square beta plus cos square gamma is equal to 1, or L represents for cos alpha, so L square is equal to cos square alpha, M square is equal to cos square beta and N square is equal to cos square gamma. Cos square alpha plus cos square beta plus cos square gamma is equal to 1. If so, the direction cosines of direct line is unique. The direction cosine of a direct line is unique, and direction cosines of x-axis, y-axis and z-axis are respectively 1, 0, 0, 0, 1, 0 and 0, 0, 1. It is sure asked in your exam. It is sure asked as a short question in your exam. What is? Direction cosines of a direct line is unique, and direction cosines of x, y and z axis are in this manner 1, 0, 0, 0, 1, 0, 0, 0, 1, etc. It is then we now discussed about the 3 dimensions geometry. Now we further discussed about direction ratio of a line. Direction ratio of a line. What do you mean by direction ratio? The number of proportional to the direction cosines of a line are called its direction ratio of the line. The number of proportionals to the direction cosines, the numbers of proportional to the direction cosines are called its direction ratios. The number of proportional to the direction cosines of a line are called its direction ratio, or the numbers of proportional to the cosines of the line are called its direction ratio. The direction ratio, if the direction ratio of a line are as A, B and C, then the direction ratio of the line is equal to its proportional. N by A, N by B, N by C are equal, where L, M and N are the directions cosine and the A, B, C are the ratios. So, if A, B and C are the directions ratios of the line, then the equation is equal to, then the proportional is the similarity of the proportional. The similarity of the proportionals are N by A is equal to M by B is equal to N by C. If A, B, C are the directions ratio of the line, if A, B, C are the directions ratio of the lines, then the directions cosines are M, M and N are in this manner. A, B, and C are the directions ratio of the line. Then the directions cosines are L is equal to plus or minus A by A square plus B square plus C square root over. The M is equal to plus or minus B by A square plus B square plus C square root over. And N is equal to plus or minus C by A square plus B square plus C square root over. Here the directions cosines are M is equal to this, M is equal to this and N is equal to this. If A, B, C are the directions ratio, here A, B and C are the directions ratio of the line, and the directions cosines are turned in this manner are L, M and N. Then directions ratio of a line pass through, if the directions ratio of a line is pass through the point x1, y1, z1 and x2, y2, z2. If the directions ratio of a line pass through, if the directions ratio of a line is passed through the point px1, y1, z1 and x2, y2, z2 where pq, then the directions ratios are x2 minus x1, x2 minus x1, y2 minus y1 and z2 minus z1. Here the directions ratio is passed through the point where the coordinates of the point P and Q are x1, y1, z1 and x2, y2, z2. Then the directions ratio passed through the 2 points are in this manner. The subtractions of their coordinates. Then x2 minus x1, y2 minus y1, and z2 minus z1. Then the directions cosines are the directions cosines are x2 minus x1 by cardinal to the pq, y2 minus y1 pq, z2 minus z1 by pq cardinal. So we reached at the conclusion, then the direction ratio of two parallel lines are proportional. Directions ratios of two parallel lines are proportional, and direction ratio of a line are not unique. Direction ratio of two parallel lines are proportional, and direction ratio of a line are not unique. Now I remain here. Tomorrow we discussed about the straight line, about the straight lines. Thank you.